Welcome to first video of cloud computing series. In this video, we'll be discussing the important topics, important questions from exam perspective. So make sure you subscribe to my channel so that you don't miss out the upcoming videos or one-shot videos for all the rest of the modules and not just cloud computing for the other subjects also. So let's get started. The first topic is cloud computing definition. So cloud computing is delivering of the computing services. So computing services here could be the servers, storage, database, network, or software. So when you're delivering all these components over the internet, it is called as cloud computing. So this allows user to access and use the services on demand without the need to physically manage or own a IT infrastructure. IT infrastructure refers to all the hardware components. For example, you require CPU, you require servers and all of that. But then by making use of cloud computing, you can avoid all these, yet make use of all the facilities provided by this over the internet. So core advantage of cloud computing is that it abstracts the complexities of physical hardware. Abstracts in the sense it hides the complexities of physical hardware and enables users to only use the sophisticated computing resources without substantial capital investments. That is, without spending a lot of money on the capital investment, on the physical hardware investment. Key characteristics. First one is on-demand self-service. On-demand self-service means users can make use of computing services automatically without any human intervention. Then we have broad network access, that is, services are accessible over the internet throughout standard devices like laptops, smartphone, tablets, and so on. Then we have resource pooling, that is, computing resources are shared among multiple users dynamically. They can be accessed by anyone over the internet. Then we have rapid elasticity, that is, resources can scale up or quickly down automatically to meet the fluctuating workloads. Then we have measured services. That is, usage is monitored here. That is, a user can use only 10 MB of memory or something like that. Okay. So, and build on pay as you use a basis, pay per use model, ensuring cost transparency. Then we have virtualized infrastructure, that is, physical hardware is abstracted into virtual resources. So this will enable efficient and effective resource allocation. We have utility computing. So computing resources are considered as utilities like electricity or water. Then we have IT outsourcing. So businesses delegate IT infrastructure management to extend cloud providers for cost and effective services or efficiency benefits. Then we have platform as service, so which provides a development environment for building, deployment, maintaining different applications. We have software as service, which delivers software applications which can be accessed via internet. Then we have scalability. The system can handle increasing workloads by adding resources or distributing the tasks effectively. So we can say that cloud computing allows businesses and individuals to avoid the cost of complexity or the complexity of owning physical servers and other infrastructure. So cloud computing provides a flexible, scalable, and cost-effective solution for a wide range of computing needs. So this was about the definition part of cloud computing. So here we have textbook definitions. These two are the textbook definitions. So cloud computing is a model for enabling ubiquitous, convenient, and on-demand network access to shared pool of configurable computing resources. These are all the examples which can be rapidly provisioned, released with minimal management effort or service provider interaction. One more definition we have says cloud computing refers to both applications delivered as services over internet and the hardware and system software in the data centers that provide these services. So here we have the figure of cloud computing vision. So if you look at this figure, there's like I need to grow my infrastructure, but I do not know for how long. So this reflects the cloud scalability aspect. That is, businesses can scale their infrastructure up or down depending on the traffic which they have. So cloud services allow them to expand whenever they want, and even the demand is less, they can scale down also easily. Then I cannot invest in infrastructure. I just started my business. In this condition, they can opt for the software as service or platform as service. They can make use of the ready to use applications which is cost effective and ideal for the small businesses, startups, and so on. Then we have, I want to focus on application logic and not maintenance scalability issues. So here again, this shows how cloud computing allows business to offload the management of infrastructure and focus on the core application. So they may not ask this in exam, but then from a general perspective about cloud computing vision, you can refer this diagram. So vision of cloud computing is to transform the IT infrastructure into utility that can be used or accessed on demand. That is utility based. So electricity, gas, water are all utilities. We pay for them and we use them over regular basis. Similarly, they are telling even cloud computing has to transform into IT, has to transform into utility. So rather than investing money on physical components, we can rent computing resources like storage, processing power, application servers on as needed basis, pay as you use basis, right? The vision is to offer numerous benefits: reduced upfront costs, that is the infrastructure costs. Scalability means multiple devices can be connected to cloud, thousands of devices. Flexibility is again, you can scale it up or scale it down depending on your requirements. And then ease of maintenance, because you don't have any hardware, you just have to focus on the application, right? You need not worry about the physical servers and all. So it is very easy to maintain it. Other benefits also. So the main vision is to create a global market space for cloud services, making trading easier for providers and consumers. Here they have spoken about trading from the consumers and providers perspective, where they can trade resources freely, breaking down the barriers between different services and vendors. So this would give great competition, improve the quality, and establish proper connection or integration between the systems here. So as industry matures, ability to easily enable computing services will help industries and individuals to adapt to their needs quickly and effectively. This also makes it easier for small businesses, startups to access powerful computing services without the need to significantly invest on the capital or infrastructure. So these points we have covered in these figures only, right? So the same thing has been written here. So moving on further, we have the impact of cloud computing on various sectors. So the first one is large enterprises. So for example, if you consider the New York Times, they had used Amazon E2, EC2 and S3 to convert digital archives into web-friendly format. So the cloud computing was extensively used for data storage and database retrieval purpose by the New York Times here. Speaking of the small enterprises or startups, for example, Animoto uses AWS for images, video processing. Benefits are very high and scalability is also increased here. For system developers, they need not focus on the system infrastructure. They need not worry about the infrastructure or hardware, what components are there, what are the processors which are used. All that is not necessary. You just have to focus on the business logic and how to improve your code or how to improve your output. Then we have end users. End users can make use of the end users can make use of the cloud computing. For example, the Apple Cloud, Google Drive to store documents, photos, videos, and so on. So these are the impact of various sectors. Next, we have environmental overview. So environmental overview, we have three parts here. First one is public cloud. So public cloud is the third party provider which is managed by the third party, and it is easily accessible, available for everyone, and it is most effective one and flexible. So that is an example of public cloud. Coming to private cloud is restricted to a particular company or particular business. So not everyone can access this private cloud. It is just restricted to that company only. So these are often chosen by business or organizations which have high security and privacy concerns. Coming to hybrid cloud is a combination of public and private cloud services. So this will allow the companies to use public cloud when their private infrastructure is insufficient. Next, we have cloud computing reference model. So this is important question which could be asked. So the way cloud computing reference model is the way we classify and understand different types of cloud services offered. So these categories will reflect different layers of services that provide various levels of abstraction, functionality, and catering different needs. So cloud computing reference model is broken into three parts: software as service, platform as service, infrastructure as service. First comes the infrastructure as service. So infrastructure as service lays the foundational layer. So this is the base layer of cloud computing where virtualized hardware resources are provided on demand. So the IaaS or infrastructure as service delivers infrastructure like virtual machines, storage, networking that can be customized by users depending on their applications. So these virtual servers, users get virtual machines, VMs that emulate the physical hardware, allowing them to run custom software. So these virtual machines, they are built on hourly basis. So pricing depends on the hardware specifications. For example, it could be CPU or memory or storage usage and so on. So the infrastructure as service offers two types of storage. First one is virtual storage, where for storing persistent data that needs to be paired with virtual machines, we make use of virtual storage. Um, Object storage is a higher level storage solution, which is more abstract and ideal for storing large amount of unstructured data. This could be files, backups, and so on. Then examples here, we can speak about Amazon EC2. EC2 is Elastic Compound Cloud. Then we have S3. S3 means the simple storage service, Google Cloud Engine, vCloud, RightScale, and so on. Speaking from the networking perspective, so it involves managing the virtual networks that allow virtual machines to communicate, connect virtual machines to outside world, that is internet, and also for managing the security, access, and scaling up of the network. So this was about the infrastructure as service. This lays is the basic foundation, the rock foundation. Then we have platform as service. Platform as service is the middle layer, which is built on the infrastructure as service. So this provides a scalable and elastic runtime environment where developers can deploy and run their applications. So here, rather than worrying about the hardware and the infrastructure, we can focus on writing the code while platform handles the scalability, availability, and fault tolerance. So scalability, availability, fault tolerance are the key aspects about platform as service. Then it provides necessary tools, software, and framework. So because it is a middleware platform as service, it will help us to develop, test, and run applications. This layer abstracts much of the complexity about the hardware management and all. Then cloud provider is responsible for managing the platform. So here the cloud provider is responsible for managing the scalability and fault tolerance, which helps the developers to not worry much about it, but then focus on what is actually needed, like writing the code, handling scaling and all of that. Examples are the Google App Engine, Microsoft Windows Azure, and platforms like Hadoop or Aneka that provide scalable environments for distributed applications. Next we have is the software as service, the topmost layer. So software as service offers the ready to use applications, on demand software applications that can be accessed through the internet, which are hosted and managed by the service provider and are accessible via web browser. So these are the end user applications. They are they include common business or consumer applications, which could be the emails, document management, photo editing, CRM, relationship management, Facebook, Twitter, and so on. So like software as service applications are shared across multiple users, millions of users online, and they have multi-tenant architecture. That is, they are shared across multiple users with each user data kept separate from each other. That's what we can see in Facebook and Twitter, right? Everyone has different application, but then everyone is accessing the Twitter at once over the internet. So that's what is the best example of software as service. It has high level of abstraction compared to the other two. Examples are Google Documents, Salesforce, Microsoft 365, and platforms like Facebook, Twitter, Flickr, ServiceNow, and REST. So we can say that software as service is like it can be useful for those who need who want pre-built applications and are not interested in managing or developing the software from the core. For such people, we can make use of they can go for software as service. Here we have the characteristics of cloud computing. Again, this is also important. So the first one is no upfront commitments. That is, users do not need to tell or make large initial investments in hardware or software. right? So cloud services are like pay as you go or subscription based model. Then we have on demand access. That is, cloud resources are available on demand. That is, whenever you need, they are available. When you pay or select a plan, they are allocated accordingly. Then we have flexible pricing. That is, depending on how much you use, you have to pay it accordingly. Suppose this month you have made use of 5 GB of data, 5 GB of storage, you have to pay relatively 500 rupees, let's say. And next month, if you are using 1 GB, then the cost would be comparatively less. It could be 100 rupees and so on. It is flexible pricing depending on the features which you are using and what is your subscription. Next, we have simplified application acceleration and scalability. So cloud computing allows easy scaling of applications based on the demands. That is, thousands of subscribers can make use of, or thousands of users can store the data over the application at once. Right. Simplified application acceleration means uh, even though so many people are accessing, there is quick response generated and rapid like application acceleration or expansion is happening here. Next we have is efficient resource allocation. That is, cloud providers will optimize the use of hardware resources across multiple tenants. They'll ensure that efficient resource utilization and they reduce any wastage happening. Then energy efficiency, because you're not using large systems, large servers, definitely you're saving energy, right? Thereby moving towards the energy efficient or green initiative. Then we have energy efficiency, and yeah, that's it. All the points have been covered here. Then we have third party services integration. That is, cloud computing will make it easy to integrate with third party services into applications. Thereby, it will help the businesses grow, create new products, improve, and yeah, develop. That's it. Next we have benefits of cloud computing. So all these are self-explanatory. You can write it on your own words. Let me just explain it. Cloud cost efficiency. Cloud computing will reduce the cost for establishing the hardware or the IT infrastructure. It converts these costs into operational expenses while users paying only for what they are using. So this will significantly reduce the upfront investment and the maintenance cost also. Then we have increased agility. Agility means organizations can rapidly deploy or adjust the IT systems as needed without planning in advance. So if demand increases, they can add more resources, use more resources. If it reduces, they can delete the subscriptions. Scalability means cloud computing services can scale up or down depending on the business needs. That is, thousands of subscribers can use it at once. Cloud is capable enough of handling large traffic or reduce the demand. When demand falls, it is also capable of facilitating the demand effectively. Then we have access anywhere, anytime. So here again, cloud services can be accessed by anyone at any time, any location. So this will improve the mobility and collaboration for businesses and end users. And then we have energy and resource optimization. That is, centralized cloud data servers are present, cloud data centers are present, which offer better energy efficiency and resource utilization compared to me having system at my home, you having system at your home. This will consume a lot of energy um, compared to one data center which is used by thousands and millions of end users. Then we have multi-tenancy. That is, cloud service providers hosts applications and services for multiple customers on same infrastructure. So these customers will share the costs, will improve the efficiency through economics of scale. Then we have improved flexibility in the software development. That is, developers can focus or they can integrate the third-party apps, third-party services, thereby creating new applications with minimal time and minimal cost. But then the efficiency and output is very high. Next, we have challenges in cloud computing. Despite having so many benefits, there are drawbacks also. Let's look into them one by one. First one is security concerns. In that, we have data protection. That is, like organizations do not have their own infrastructure, right? So they have to trust the cloud provider with the data. Suppose if I am dealing with very confidential data, then data security becomes a critical concern, especially when data is stored not in our office, not in our cities, where it is stored somewhere outside. So there, there is chance of unauthorized parties to access my data, thereby data concern or the data concern or data security is a major concern here. Then virtualization risks. That is, data can be exposed in memory during processing, making it vulnerable to malicious acts, which could include providers who have to access the underlying infrastructure. Then we have legal and regulatory issues. Data privacy. That is, for in some countries, accessing certain data might be allowed, whereas in some countries it is not allowed. So the data privacy varies depending on different geographic locations. Different countries have varying laws about data privacy, right? So again, it is a threat. Jurisdictional concerns. That is, when data is stored in multiple locations, it becomes challenging to navigate the legal implications, especially when government from different jurisdictions seek access to the data. Suppose if I am storing Karnataka government data in Africa data center, and there is definitely a threat to the government data here, right? So anyone, a third party or an attacker might be able to access the data. So again, that is a challenge. Then we have dynamic and resource provision. So determining the proper amount of resources to allot and what is the duration for which they are required is a challenge. It is not, I cannot predict it, right? So over giving leads to unnecessary costs, while under giving can lead to reducing the performance, right? Then we have integration with existing infrastructure. So integrating cloud-based resources with the existing systems, computers, and processes can be complex because businesses may encounter issues dealing about the compatibility, security, and performance during such integrations. Then we have vendor lock-in. That is, cloud services consumers might find it difficult to move their data and applications from one provider to another provider. That is again an issue. Then we have downtime and reliability. When cloud providers offer high levels of reliability, there is still risk of outrages. That is, dependency on external provider means organizations have to manage the potential risk of service interruptions, downtime, and which could affect the business if you are running like a stock market or something. So each and every time, each and every moment is very important for you. At that time, if your system goes down, it could lead to loss in your business. Right. Next, we have historical developments in cloud computing. So, cloud computing's evolution is deeply rooted into development of distributed computing technologies over decades. So, here we'll be discussing few of the milestones and technologies that have led to rise of cloud computing. So, the first one is distributed systems. Distributed computing. So, they are the core technology behind cloud computing. So, a distributed system will comprise of multiple independent computers that work together as one particular system. So they are unified entity to the users. So this concept or this idea is crucial for cloud computing, where multiple resources like infrastructure, runtime environment, services are shared among multiple users. Key features can be scalability, transparency, continuous availability. All these are the fundamental aspects of cloud computing, right? So here our primary goal of distributed system is resource sharing. So which is extended in cloud computing also. So in cloud computing also we are renting the infrastructure and services to the users, right? So we are allowing the companies to optimize the utilization depending on their computing resources. Looking at the key milestones in distributed computing. First one is mainframe computing. So mainframes are the large computational facilities. They are also called as supercomputers. Okay, they rely on multiple processing units. So they were used in 1950s to 1970s. So these systems were highly reliable, capable of massive input-output operations, making them ideal for intensive data tasks like transactions or enterprise resource planning and so on. So though mainframes are not used these days, they have evolved. They are the foundation for evolution of cloud computing. Next, we have cluster computing. So cluster computing were used in the 1980s. So with the advancement in technologies, clusters of commodity clusters of commodity machines became a cost-effective alternative to the mainframe and supercomputers. So high performance computing becomes accessible to a broader group, including small research labs or universities and so on. So cluster computing has laid foundation for modern distributed computing contributing to development tools like parallel virtual machine, message passing interface, and so on. Then we have grid computing. This was invented in 1990s. Grid computing evolved from the cluster computing, where geographically dispersed computing resources are all interconnected through internet. So it is grid computing allows the users to access the computational power and storage for multiple organizations, creating a large scale distributed infrastructure. So here again we are making use of the consume. So we are making use of a model like utility based model where consumers or the users will consume the resources as needed, much like electricity or water, which are also considered as resources. So here mainframe plus clusters plus the grid computing led to the main in mid 2000s cloud computing was evolved. Next we have is virtualization. Virtualization is a technology that will allow the creation of virtual computing environments within a physical machine. Suppose I have one system. In this system, I'll be able to run only one operating system, right? So whereas if I'm running Windows or Linux in same operating system in same device, then it is an example of virtualization. So these environments will behave like separate or independent machines, providing ability to run multiple software stacks on same physical hardware. Same physical hardware is there, but then depending on my usage, I'm making use of different components here, different software stacks here. So in the context of cloud computing, virtualization enables several core functions. Several core functions in that first one is the resource abstraction. So resource abstraction means it abstracts the physical layer like the storage, CPU, network. All these are abstracted, and it allows multiple virtual environments to share same hardware without interfering with each other. Then you have customization. So it is the tailored virtual machines with specific software stacks are used. So here we can customize them depending on our usage or application. Then we have on-demand scalability. That is, cloud services like Amazon EC2 makes use of virtualization to provide scalable and customizable computing environments that can be provisioned and decommissioned as needed or as required. Then we have the virtualization types, which include the hardware. So it simulates hardware resources to run full operating systems in virtual machines. Process, storage, network virtualizations are also there. 2.0. Web 2.0 is a revolution from Web 1.0. Web 1.0 had static applications, right? So an advancement over this static applications is Web 2.0. So this is evolution of internet from static collection of web pages to dynamic platform for interactive applications. So it emphasizes user engagement, content sharing, collaboration tools, rich user experience are all some features. So rise of Web 2.0 has influenced the cloud computing in increasing the interactivity. That is, Web 2.0 helps to become more interactive and user-centric applications. So uh, like by this, the cloud computing can be accessed via web browsers without requiring local installations and all of that. Then collaboration and social interaction platforms like Facebook, Google Drive are all user-generated content and collective intelligence. People can access it, provide their content accordingly. Then rich experiences, that is Web 2.2 powered technologies like Ajax will allow faster and more dynamic web pages. Technologies enabling Web 2.0 include XML, Ajax, web services, and RSS. Examples of these include Google Maps, YouTube, Facebook, Wikipedia, and so on. Next we have is service oriented computing, SOC. So service oriented computing is a design philosophy where the software applications are composed of discrete reusable services that communicate over network. This approach enables rapid, flexible, scalable system development. Key aspects of software service oriented computing include first one, loose coupling. That is, services are independent of each other and they can be reused across different applications. Then you have interoperability and software as service. So services can be written in different programming languages, deployed on different platforms, but still they can interact with each other easily. Then software as service means software like multiple softwares could be created. They can be used accordingly, like Google Documents, Salesforce, and so on. So here we need not worry about the infrastructure. Location transparency. So irrespective of the location, it could these applications could be accessed by anyone everywhere, and the user's location is also depicted here. Abstraction, that is hardware level is abstracted here. Only software is focused. Then quality of service. Quality of service is focused here as you are providing the service here as a utility. Okay, so this service could be the web applications which you are hosting. Next we have is utility oriented computing. Utility means we have electricity, water, all these are utilities, right? So utility oriented computing means concept of providing computing resources as pay per use model. So this model is akin to like utilities that are provided to the consumers. Key features are pay per use model. That is how much ever resources I am renting, I'll be paying only that much. On demand availability. If I require resources, I'll be getting it, and if I don't want it, I won't get it. So upfront investment is not required here. And we have e-commerce and online platform, online payments of in various platforms. So the rise of e-commerce platforms have helped in growth of the utility based or utility oriented computing. So the idea of utility computing dates back to 1960s, where John McClary envisioned computing as public utility, and in present world this has become the truth. This has become the existence, right? Whatever he envisioned has come into reality. Now we'll look into building cloud computing environments. So building cloud computing environments both involves both developing applications and systems that leverage cloud solutions and creating frameworks, platforms, and infrastructure that deliver cloud services. This process requires knowledge across the range of technologies. Key aspects of building cloud computing environment includes first one is application development. So cloud computing provides scalability and flexibility, making it proper and making it ideal for applications that experience fluctuating workloads. That is, today I have high usage of data, tomorrow I may not have. Today I have high demand, tomorrow I may not have. There are two categories: web applications and resource intensive applications. Web applications are highly interactive, so they have the complex systems that can handle varying user demands. For example, Web 2.0, it has rich user experience and then seamless delivery of enterprise grade applications through internet. Dynamic resource allocation and all happen in web applications. Resource intensive applications, so these will include compute intensive or data intensive applications. For example, the scientific research or large scale simulations, all these come under the resource intensive tasks. So these applications often demand substantial computation power because power for short durations, making cloud computing economical and proper or practical solution. So cloud computing supports these applications by offering scalable compute power, storage, and networking resources. First one. Second one, they offer providing runtime environments tailored for dynamic resource allocation. Yes, and then they deliver managed application services resembling the desktop services or desktop software. So here developers use the web-based RESTful interfaces for accessing cloud services, ensuring simplicity and ease of integration. Next, we have is infrastructure and system development. So cloud systems are inherently distributed. We know requirements like vary in distributed computing, right? So by making use of virtualization, Web 2.0, and then the service orientation, we can meet all these. So key challenges here are, key components: virtualization, middleware, scalability, distributed computing, Web 2.0 are all part of it. Virtualization means you're employing virtualization techniques in core element in building the cloud infrastructure. Middleware means it is used to deliver the infrastructure as service, and programming language virtualization, which is leveraged as platform as service offering. Scalability means you're designing systems with scalability, fault tolerance in mind. So these considerations will influence the design of cloud-based systems, focusing on managing the demand component, how to deal with them, how to create the system, and other utilities. Next we have is the cloud computing platforms and technologies. So cloud application development leverages various platforms and frameworks. There are various platforms, frameworks. right from a basic one to a specialized or customizable service. So these platforms will help the developer to focus on application functionality while relying on cloud for scalability, reliability, and resource management. So we'll look into the softwares or the platforms which are present, key platforms and technologies. So this is an important question. So the first one is AWS. AWS is Amazon, is provided by Amazon. AWS is a leading provider of cloud infrastructure and services, offering a comprehensive suite of tools. The tools here include Elastic Cloud Compute Cloud, that is Amazon EC2, which has customizable virtual hardware for deploying. Then it has options including GPU and cluster advances. It supports deployment in AWS console and web services API. It allows saving running instances as templates which are stored in the S3 and simple storage service, that is S3. It has persistent scalable storage organizations into buckets for storing binary data of any size. Then additional services like networking, domain name system, caching, database, relational or non-relational are all managed in the Amazon Web Services. Next we have is Google App Engine. So App Engine is a scalable runtime environment, that is platform as service for web applications, providing high performance and dynamic scaling. Features are secure execution environment for applications, services like memory caching, scalable data storage, job queues, messaging, and uh, cron tasks are performed here easily. Development support includes the SDK for local development and testing, easy migration to application environment with cost management via quotas, and multiple programming languages could be used, and resource optimization is done here. It supports multiple programming languages and all. Next we have is Microsoft Azure. Microsoft Azure is it is provided by Microsoft. Azure provides a scalable cloud platform for web and distributed applications. So this is very specific to software as service. Roles. First one is web role. So it hosts the web application. From a worker perspective, it is a generic container for workload processing. Then from a VM role, it is fully customizable virtual environments, including the OS configurations. Additional services include relational data storage, blob, that is binary large object data storage, networking, caching, and content delivery. Then we have Apache Hadoop. So Hadoop is an open source framework for processing large data sets using the commodity hardware. Core components include the map reduce, that is programming model for data processing, map which will transform and synthesize the input data, and reduce which will aggregate the map outputs. Then we have HDFS, that Hadoop distributed file system, which is scalable storage for large data sets. Then from the enterprise usage, Yahoo sponsors and uses Hadoop extensively for its cloud infrastructure. Then we have Force.com and Salesforce.com, both are same. So Force.com is a platform for creating social enterprises, applications and forms, the foundation of Salesforce. Salesforce is famous for the CRM, ERP applications and all. So the features here are ready to use components. It supports for customer, like customizability is one more aspect. Development capabilities are design of data layouts, business rules, workflows, and user interfaces can be easily done in this software as service platform. And the web services for accessing functionality and hosted the applications. Aneka is a cloud application platform that enables scalable application development and deployment. So programming abstractions, that is, it supports tasks, discrete threads, and map reduce models. When speaking about the runtime environment, it is distributed and service oriented. It is deployable on heterogeneous hardware. Then dynamic interaction of resources on demand is also one more feature here. Services are runtime management includes scheduling, execution, billing, storage, and quality of service. So all these platforms, no, they represent major cloud computing technologies across infrastructure as service, platform as service, and software as service categories. So they illustrate different use cases, enabling developers to choose the one according to their requirements. So in this video, we have tried covering all the important topics from exam perspective. Make sure you don't miss out any of the topics which I have told as important. And stay tuned. I'll be uploading the second module and third module pretty soon. If you have any doubts, do let me know in the comments. And thank you.